Okay, welcome to Math 2930 or Intro to Probability and Statistics for engineers. Although this is for engineers, most other statistics this will follow along. It's just for this course, there'll be a lot more fast-paced. So out of everything chapter 1 is, we're going to do chapter 1, and today we're going to do 1.1, which is just definitions, mostly today. Definitions. Disregard my spelling, but you know what I'm kind of talking as I do it. So we have to get the bullshit out of the way. So today we're going to go over different definitions and different things that is very important for probability and statistics. So the first thing we're going to go over is our population. We can define this as a capital N, and a population is the entire collection of individuals or objects to be studied. So this includes everything in the entire population. So let's say the population of a city, it counts every single person that lives in that city. So let's say Toronto, if I'm trying to do a statistic on whatever, let's say how many people in Toronto go watch the Raptors game, I'm going to take the population of specifically just Toronto and not anywhere else outside the GTA. So a population would use an example of population of Toronto. But our next definition, so I'll highlight all of these definitions just to make it a little bit easier to kind of see. Our next one is our observation, which this is just easy. This is a basic definition. This is a single entity. Entity or measurement. So this is just what you notice. So out of, let's say it'd be these people who go to a Raptors game, how many people are over 6 foot? So your observation, maybe it narrows it down just a little bit more. So a variable is a characteristic of either the population or the object of the population. So as I highlight this, it's a characteristic of an object. So it might be an interest. So for example, right, let's say values of x, right, values of y, values of fx, right? We could define these as in graphs, basic entities, but we can also define them as, so let's say we have a plot of a graph. This is y, x, of course. We can define x as time. Time is always infinite. It's always going forward. We can define y as time, and then let's say y is just height. So as it increases, right, as age, right, you might hit the peak height and then you might slowly go a little bit down. So this could be a variable that we characterize this object from. And our last one we're going to do, I'll write it down here, is our sample. So our sample, this one's very important. I'm going to explain kind of how our population, I'm going to start this one too, and our sample relate to each other. So it is a subset of the entire population or, so I'm going to put a comma here for or, a small selection. I'm going to use the same word of objects, right? Objects are individuals, which is either one, but just a small selection of objects taken from either the whole or some of the population. So, and I'll put a note and can be taken for the whole population. So how these guys relate? So when this sample will be with a lower case n. So population is usually at higher case n, capital M. Sample is a lowercase m. So as we move on, kind of our definitions, this is what our population for a sample for. So we're going to do an example. on our next slide. So I'm going to turn this over. Example. Let's just do 1.1. Just that's what the chapter we're on, the chapter of the text we're going to be using. I'm going to kind of destroy it in the link as well too. So in this example, we're interested in heights of Canadians. So can, I'm just going to put can, and then children. Aged 5 to 9 years old at 2018. Let's just put a random year. And this one will be this is going to be approximately, let's say, 2,000 kids. So 2,000 kids. So our population in this example, so I'm going to actually change the color. So our population in this problem is the 2,000 kids. Sorry, I apologize. So it's not the 2,000 kids. We can define that as n, but it's going to be the 2,000 kids. Actually, let me read it. So it's going to be 2,000 kids in Canada aged 5 to 9. So this is our population. The variable in this, so the variable is what distinguishes. So I'm going to highlight each in different colors. So the first one, our population, is going to be in yellow, Canadian change in 5 to 7. And next, our variable is going to be the height. So in our ages 5 to 9 years old, different heights, which I'll highlight in pink, around these age groups. So I'm going to put a variable height, right? This would be X, Y, Z, right? P, Q, R, X, Y, Z, anything under the fucking belt. So our next one is our observation. This can be a single height. So a single height of a child, or it could be each child. So it could be a single one, 10, 20, 30, or every single one out of that. What you're observing is the height. The census can be described as measuring and recording. So we're measuring and recording in this all heights of the population. So I'm going to all heights of n. So I'm going to highlight this as well too in pink. All heights of n, which we know n in this scenario is our population. So we have another one. So I'm going to change the color to blue. So I'm going to actually keep it consistent. I know for me, I like the same color, but other people might not like that. So our next one. So this would be 1. 2, our next kind of problem is 2, I'm going to put this in black as for questions. Design one sample size. So remember our samples is lowercase n. So let's say n equals 100. So how we can design this, I'll put it in red. School, spelled that wrong. School A chooses 100 students between 5 to 9 years old. Why we create a sample is so we can take a larger amount, sorry, not larger, to take a smaller amount than the given population. So usually, put this back in black, so I'll start this. Usually samples are small. So this is kind of a sample of a population, right? Instead of giving the population of Canada, I want a population of a city, right? So a sample size of that. And populations usually are large. The larger. So we created samples because it's easy to make it a little bit smaller and a little bit easier for what we need to do. another example of just kind of visualizing it. So let's say if I draw a circle over here, and let's just say I draw three blue dots, one red dot. I make this A, B, and then why not D? So everything, right, that is highlighted, so everything that's outside the circles, we can define. So the yellow is the population. So let's say it's the population of a lake. So this is everything the lake's the entire population. This is the whole lake, or I'm sorry, the population, the whole city. And these little parts, let's say A, D, B, are samples which are part of the population. So as we want to do a sample, we make it a little bit smaller as we go. So now we have our next one, which is 1, 2, the different types of samples. So now we understand the difference between sample and population, but now we got to understand the different types of samples that we will experience. So there's going to be 2. So I'm going to turn 2 different colors. So I'm going to put 1, 2. So the first one is going to be my random sample. Next one is going to be my convenience sample. So both are samples. The random sample is randomly chosen. So let's say so for random sample, I'm going to put an arrow down here. Let's say I have a bag. I have a bag of balls. So let's have a bag of balls, and I'm going to close my eyes and I'm going to reach into this bag of balls and grab a red or a blue ball. And the random sample from this is I can either pick red or blue, but it's random because I'm not trying to get the ball. I'm just putting my hand in and see what I get. So this one is randomly chosen from the population, and each one has the same chance. Same chance to receive or get. I'm going to add that part. So it's same or equal chance to get. That's very important. Convenience is chosen. So you'll notice these 2 words. I'm going to highlight this. Random, chosen. So one is randomly selected. One is chosen for our best data. So we're going to use another example. So we're going to example 1.2. So we are interested in grade 9 math scores. Let's say in Ottawa. We're interested in grade 9 math scores in Ottawa. So we have 2 samples. So our 2 samples are the following. And we have to define them. So choose one class from one high school. And our second sample is randomly draw a box with student IDs. So as we go in, I'm going to write this in black again. So we have to define them. So number 1. So remember our 2 conveniences, random and chosen. So the first one is our convenience sample, because we are choosing a specific school and a specific class that we want to use this experiment math courses. The next one, as you know, is the other one, random sample. This is because each one is randomly drawn from a box of student IDs in Ottawa to get the scores. The question is, which one is better? In this scenario, random sample is better. So random sample is better. This is because when we try to do a statistic, especially like this, so let's say we want to do grade 9 math scores to make sure to see, okay, how are grade 9s performing in Ottawa. If we choose one class and one high school, we could be restricted. So we could be restricted in our data. But with a random sample, it's random and each person has a different chance to perform high or low. So now, as we try to distinguish them from the samples, remember we have two samples, random over here and convenience as we go up. So now as I scroll down, I'm going to go for now. It's the actual introduction to this course. So far, a little bit of review. Went over population. Most importantly, we're going to know over population, sample, and our variable. Right. So sample as we go up here, population, sample, and variable. So characteristics of populations and sample sizes, small of the population. So as the next one, so put 1.13 just to distinguish it. I'm going to do probability now. Versus a statistic. So the kind of basic thing we're going to be doing this entire course on. Right? Probability, construction probability statistics for engineers, or even just any general person who has taken a probability and statistics course, would be psychology or the kind of degree under the boat. So a probability is assuming the population is going to be known. So as we define these, so we want to define them as problems. So probability problem. So I'm going to put question. And is characteristics of a population, remember defined as N, is keyword, I'm going to change colors, assumed to be known. Because it's assumed to be known, we can answer the questions for our sample for the population. So because we know the characteristics of our population, we can derive a sample from that population. So then a statistic problem, a stat question, we assume little known. So I'm actually going to change these keywords. I'm going to highlight this in yellow. So known and little known. Right? Because we know a little about the problem, we use the information gathered to contain a sample and generalize what we're going to do. So to better kind of show this, what we're going to do, we're going to show a relation. I'm going to do it over here. So relation for probability and statistic. So I'm going to do two graphs. So I'm going to do one black circle, one red circle. I'm going to do two arrows in between. Because even though they're different, they go back and forth. So in this black circle is our population, defined as N, uppercase N. And then on our red corner, kind of like two fighters in a UFC fight, is our sample, which is defined as lowercase n, as we remember. So to answer these, right, to answer population to get our sample, we are defined, because remember, population, we know a lot of. We know a population, know what we're going to go for. So the population go for a small from population. The sample, right, it goes smaller. We know the probability. And then that a sample to a population, we'll use it as a statistic. So, for example, sample to population, right? How many people in Toronto walk to work, right? So we take the population of Toronto, relate it back to the sample with a probability of how much actual people walk, and we relate it back to the statistic of how many people in Toronto actually walk to work. So our next example is actually going to get into the probability aspects of what we're going to do. So example, so I believe the other ones are an example 1.2. This is going to be example 1.13. Okay, so a box has 7 red balls and 3 blue balls. So I'm going to draw them out. So we have 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3. So as you do it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So imagine this is in a bag or a box. In this case, actually a box. So as we do this, we're going to randomly select. We select one ball. As you randomly select one ball, the question is, what is more likely to occur? So this is the question we're going to answer. So this is our problem. A box has 10 balls, 7 red, 3 blue. When you randomly select one, what is more likely to occur? So in this scenario, our population is 10 balls. Right? We have population 10 balls are in this box. Our sample is the red and blue balls. So in this first part of this question, we can answer it. I'm going to answer it in pink right now. Right? So basic probability we've done from high school, even elementary school. Out of all these 10 balls, because we have 7, the probability is 7 out of 10. So the 10 is our population, and the 7 is the 7 red balls present. Right? And as we want to comma this, so then it's because there's 7 here, we have to randomly choose the blue ones. So as we have 3 blue out of a population of 10 balls in the box, so then both, this one equals 70% chance, and this one equals a 30% chance. So the answer to this question is red. So red is probably more likely to occur just because when randomly selected, a red ball, I might pick up more, 7 out of 10 times versus a blue ball, which is 3 out of 10. The next question is, so the same box contains red and blue balls. But now, I'm going to put part 2. But now, we randomly select one ball, and then we record it, then put it back. We repeat this 10 times. So we've done it. We pick a ball up, put it back down 10 times. The chosen are the following. I definitely spelled that wrong. That's okay. The following. Right? So I'm going to write this in, I'm going to write a new color, purple. Are the following. So we have, when we picked it up, we got red, blue, red, blue, 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 red, red, red. And last one, red. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We pick up the balls, and then as we go on. So n, population is 10, because it's 10 balls we picked up. But now we have to, the question is estimate the portion of red balls in the box. And box. Okay, so now, as we know from this, make a big arrow, number of red, if we count, we have 1, 2, 3, 4, 5, 6. So we have 6 red balls. 6. Number of blue, as we can count this, 1, 2, 3, 4, is 4. And we have this number of balls in the box, but our lowercase n is our selected balls. Selected balls. right? Our variable in this situation is the color, right? Which color we pick, and our sample size, 10, because there's 10 balls in it, right? As we keep going now, we can estimate, okay, out of all of these, number of red, we can estimate that there's going to be 6 in there, right? If we want to estimate blue, we can estimate we have 4 in there. So just estimating how much, what it is. So from a population to a statistic, we're trying to theorize, instead of now 7 out of 10, we do 6 out of 10, and out of 3 out of 10, 4 out of 10. So a 60% chance and a 40% chance. So a little bit of review as you go back up. Learn about probability versus a statistic. Characteristics are known in a probability, little known statistic, and they relate to each other in the following. Using this practice problem, we can count the probability of randomly selected a ball, and then repeating the randomly selected ball more than once. So then trying to find the probability of picking up multiple times. So then our last one, we're going to go for today. Start a new page. Is types of data. So we have types of data that we gain, whether it be data from an Excel sheet, data we get from the weather station, or data we just receive. And then every day it can be from a grade or it can be anything that can be grouped. So the first type of data we're going to be categorizing today is basically what I just said. Category. So categorical data. Or categorical instead of data, variable. Right? Because remember variable X, Y, Z. So it could be non-numeric. So it doesn't have to be a number, right? It could be how many apples are on this tree, right? And can be grouped. Right? It could be the temperatures of the weather, how it changes, apples on a tree, it could be anything. So out of these are substituted into 2 categories, put in little boxes. Ordinal, if I said that correctly, is a categorical variable, but has a set of values that are possible, has order. So it could be 1, 2, 3, 4, or heads, 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 tails, tails, tail. Let's say you have an even dice, 50% chance, and for 3 times you already know heads, tails, or instead of order, 1, 2, 3, 4. Right? It's going to go up in an order. Next one is my nominal. So this one, the keyword has an order. This one, same thing, same definition, set of values has no order. So a little bit more random, right? So say we're going to try to predict the balls, remember back in the height, or even there's numbers. So it'll be 4, 2, 1, 3, and in the or, tails, heads, tails. So keeping it a little bit more random. Our second type of data is numerical. Right, so our numerical data this is very important. So I'm going to actually start this because we're going to do a lot of problems with numerical variables and then 2 categories in it. So I'm going to actually put this in little dots because little dots are pretty cool. Is discrete and continuous. So you might have seen this in other math classes, or if this is the first time, I'm trying to explain it as best as I can for you guys. So our discrete one is numerical. So if you find a discrete variable, it's numerical. The keyword, they're infinite. They're finite. I apologize. So they're finite. I'm going to highlight this. Finite. Or countable with infinite possibilities. Right? So, for example, all real numbers, or an example of this, I'm going to put down as an integer. Right? X domain, it could be domain, so an X value could be all real numbers, right? And infinite on the x direction, or in the negative direction of x. Let's say, for example, so continuous is our values are in intervals. So our values are intervals. S on the end, so it's plural. So it's intervals. So our data now can be categorized to two things: discrete and continuous, or numerical and categorical, right? So as remember, I'm actually going to erase this. I'm going to make it a little more easier, a lot more easier. So remember our two ones, numerical, categorical. So NUM and CAT. So categorical on the bottom, numerical on the top. Numerical, discrete continuous, so DIS, CON as continuous, and categorical, we can do ordinal as up here, or nominal as down there. So that's how we can categorize them. So now our example we're going to use, actually I'm going to go on the next page just so we have space. 1.3. So we go back to that population that we did before. So let's say population and of Canada, kids 9 to 10. So let's say that's our sample. Let's do a sample of 100 children. So we're going to categorize these types of data in our measurements, or what we're trying to do. So the first one we're going to do, or try to get, I'm going to do it in blue. We have to measure plus record. So, and record height. So in this one, we're measuring and recording height. So our variable is, remember, so our height. So because our variable is the height, this is going to be numerical because height's a number, right? You can't be 10, well, you could be 10 apples high, but even that has a number doing it to it, right? It could be 2 meters or whatever meters of height you want to measure, right? 1.5 feet, right? SI units or imperial units, whichever one you're doing. But even if you use 10 apples, 10 pears, 5'2", 6'2", right? It's using a number to categorize their height. Because of this, our answer is going to be in red. This is going to be numerical. Which means there's two types of numerical. There's discrete and continuous. Because height stops at a certain point, right? We don't become 1,000,000 feet tall. Values are going to be in intervals. So this is going to be continuous. Because we have variables, let's say, from 5'2" to, let's say, 6 feet. Let's say these 9-year-olds are like going to the NBA. Let's just say that. They're a basketball player, right? So this is kind of where our data might lie on, hypothetically. Number 2. We want to count. Now, count. We got to do plus record. Teeth. So actually, instead of teeth, a number of teeth. So again, this one is going to be numerical because we're counting the number of teeth in intervals, right? So they're not going to have 1,000,000 teeth in their mouth. It's going to be continuous. But because of this, because remember in numerical, we're trying to find a numerical number, right? We are trying to, add a note here, numeric, just so it's easier for you, easier for me. This is going to be discrete. Why? Because the values are finite. Right? You can only have a set number of teeth. While in the height, even though it could stop at continuous from being 5'2" to 6 foot, That's just an example of what our data could have, right? So for example, if we go back to numerical over here, change the color to brown, right? You could have 1 foot or 100 feet, right? And these heights can vary from units, 1 meter, 150 centimeter, while in the teeth, it's finite. So you only have those possible values to go from. So now 3, we're going to find, or sorry, not find, record gender. This one is going to be, instead of numerical, categorical. Why? So remember, if we go back to the definition of categorical up here, a non-numeric number or value, but can be grouped, right? So this one, with the definition, if you scroll up again, has no order, so it's going to be nominal. I think I spelled that right. Yes, I did. So no, it doesn't have an order, right? So we record their gender of when we choose random sample 100 children, right? Just to categorize the two and just go for boy and girl. So we can be boy or girl just for this study, right? So we can have boy, first one, second one boy, third one girl, fourth one girl, fifth one girl, and so on, right? Until we get to 100, which can either be boy or girl. And that's how it is, right? It's not an order, and there's no order between the genders when we're doing the study. And the last one we're going to do before we finish this video off is overall GPA. So record the overall GPA. This one is also categorical. Why? Because we're trying to categorize a mark, right? A mark or a value. It doesn't have to be, it's not numeric, because it's not a number that we're trying to find like height. It's just a grade point average. So, and because of this, because it has a set of values and it has an order, right? Order could be from D, at least in Canada, C, B, and A, right? Excluding fail, just to make sure, because we don't want to fail. Because of this order increasing equals a better grade, right? Letter grades have order. And because of this, we can categorize this as equaling ordinal. Why? Because it has an order and it's a non-numeric value and it has a set. So thank you for watching this video today. I hope you guys enjoyed it. So what we reviewed our types of data, our different types of sample data, and we defined definitions containing population, observation, sample, and vice versa. So I'm going to end it off going down over here, just so when we get into the next video, we can start off right from here. As we got all the definitions out of the way, we can start doing some math like mean, standard deviation, and all that beginner fun stuff. Hope you have a good day. Bye.